हे शॉर्ट आन्सर. सेकंड याची आन्सर की आहे बघा. फर्स्ट क्वेश्चन, फाइंड द एम्प्लिट्यूड ऑफ द रिझल्टंट वेव्ह प्रोड्यूस ड्यू टू द. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने 2023मध्ये क्वेश्चन बँक फिजिक्सच्या विषयाची पाठवली होती. त्याची आज आपण आन्सर की बघणार आहोत. चला तर मग त्या विषय आन्सर की बघूया. आज आपण शॉर्ट आन्सर सेकंड बारची आन्सर की बघणार आहोत. हे शॉर्ट आन्सर सेकंड 3 मार्कीचला असतात. त्याची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे शॉर्ट आन्सर सेकंड याची आन्सर की आहे बघा. फर्स्ट क्वेश्चन, फाइंड द एम्प्लिट्यूड ऑफ द रिझल्टंट वेव्ह प्रोड्यूस ड्यू टू द इंटरफरन्स ऑफ टू वेव्स गिवन ॲज y इज इक्वल टू a1 sin omega t, y2 is equal to a2 sin into bracket omega t plus phi. Answer, expression for the amplitude of the resultant wave. First, consider two waves having the same frequency but a different amplitude. A1 and A2, let these waves are different in phase by phi. Second, the displacement of echo waves at x is equal to 0 is given by as y1 is equal to a1 sin omega t and y2 is equal to a2 sin into bracket omega t plus phi. Third, according to the principle of superpositions of waves, the resultant displacement at x is equal to 0 is y is equal to y1 plus y2. Therefore, y is equal to a1 sin omega t plus a2 sin into bracket omega t plus phi. Y is equal to a1 sin omega t plus a2 sin omega t cos theta plus a2 cos omega t sin theta sin phi. Y is equal to into bracket a1 plus a2 in cos phi sin omega t plus a2 sin phi cos omega t. Let a1 plus a2 cos theta is equal to a1 a cos theta equation first. A2 is equal a2 into sin theta is equal to a sin theta equation second. Therefore, y is equal to a cos theta sin omega t plus a sin cos omega t. Therefore, y is equal to a sin into bracket omega t plus phi theta. For this is the equation for the displacement of the resultant wave. It has the same frequency as that of the interfering waves. 5. The resultant amplitude as given by the squaring and adding equation 1 and 2. A square cos square plus a square sin square theta is equal to a1 plus a2 cos phi in whole square plus 8 a2 square sin square phi. A square is equal to a2 square plus 2a1 a2 cos phi plus a2 square cos square phi plus a2 square sin square phi. Therefore, a is equal to under root a1 square plus 2a1 into a2 cos theta plus a2 square. Second, show that even as well as odd harmonic are present as a overtone in the modes of vibrating of the string. First, fundamental modes. If a string is stretched between two rigid support and is puckered as it is center, the string vibrate as shown in figure. Lambda by 2 length आहे. B. It consists of an antinode formed at the center of nodes at the two ends with one loop formed along its length. C. If lambda is a wavelength and L is the length of the string, then length of loop is equal to lambda by 2 is equal to L. D. The frequency of vibrations of the string n is equal to V lambda is equal to 1 upon 12 under root T by M. Therefore, since V is equal to under root T by M, this is the lowest frequency with which the string can be vibrate. It is the fundamental frequency of vibration of the first harmony. Second, for second modes of first overtone. For first overtone of the second harmonic, two loops are formed in these modes of vibration. Diagram आहे. B. There is a mode at the center of the string and it is both ends. C. If lambda 1 is the wavelength of the vibration, the length of one loop lambda 1 divided by 2 is equal to 1 L by 2. Therefore, lambda 1 is equal to L. D. Thus the frequency of vibration is given as n1 is equal to 1 upon lambda 1 under root T by m. Therefore n1 is equal to 1 upon L under root T by m. Comparing the fundamental frequency, and therefore n1 is equal to 2n. Thus the frequency of the first overtone or second harmonic is equal to twice fundamental frequencies. Third, for the third mode of second overtone, the string is made to vibrate in such a way that three loops are formed along the string as shown in figure 3 lambda 2 under root divided by 2. डायग्राम आहे. B. If lambda by 2 is the wavelength of the length of one loop is lambda by 2 divided by 2 is equal to L by 3. Therefore lambda 2 is equal to 12 under root 3 and 12 divided by 3. See, therefore the frequency of vibration is n2 is equal to 1 upon lambda 2 under root T by m. Therefore n2 is equal to 3 divided by 12 under root T by n. Comparing the fundamental frequency, therefore n2 is equal to 3n. The frequency of second overtone or third harmonic is equal to thrice the fundamental frequency. Similarly, for higher modes of vibration of the string, the frequencies of the vibration are as 4 and 5 and 6 and pn. Thus, the even as well as odd harmonic are present in overtone in modes of vibration of the string. Third, state and explain law of vibration string. Question number 3. Answer. The fundamental frequency of vibration string under tension is given as n is equal to 1 upon 2L under root T by n. From this formula, three law of vibrating string can be given as the following. Law of length. The fundamental frequency of vibrations of the string is inversely proportional to length of the vibrating string if the tension and the mass per unit length are constant. Therefore n is directly proportional to 1 by L if T and M are constant. Second law of tension. The fundamental frequency of vibration of the string is directly proportional to square root of the tension in vibrating length and mass per unit length are constant. Therefore n is directly proportional to under root T if L and M are constant. Third law of linear density. The fundamental frequency of vibration of a string is inversely proportional to square root of mass per unit length linear density if the tension of vibrating length of the string are constant. Therefore n is directly proportional to under root T under root M if T and L are constant. If R is the radius and rho is the density material of the string. Linear density as given as linear density is equal to mass per unit length is equal to volume per unit length into density is equal to pi r square L divided by L into P is equal to pi r square rho, as n is directly proportional to 1 upon under root m if T and R are constant. We have n is directly proportional to 1 upon under root pi r square rho. That is n is directly proportional to 1 upon under root rho, and n is directly proportional to 1 upon r. Thus, the fundamental frequency of vibration of the stretched string is inversely proportional to the radius of the string and the square root of the density of material vibrating string. Question number 4. Two wires of the same material and same cross section are stretched on a sonometer. One wire is loaded with 1 kg and another loaded with 9 kg. The vibrating length of the wire is 16 cm and its fundamental frequency of vibration is same as that of the second wire. Is calculate vibrating length of the other wire. Solution. Given m1 is equal to 1 kg, m2 is equal to 9 kg, a1 is equal to a2, m1 is equal to m2, where m is the linear density of wire. L1 is 16 cm is equal to 0.6 meter and 01 is equal to n02. To find vibrating length of the wire L2. Formula. N is equal to 1 upon 12 under root T by M. Calculation from formula. N1 is equal to 1 upon 12 1 under root T T1 divided by M1. N2 is equal to 1 upon 2 L2 under root to T2 divided by M2. N1 is equal to N2. Therefore 1 upon 2 under 2 L1 under root T1 divided by M1 is equal to 1 upon 2 L2 under root T2 divided by M2. Therefore 1 upon 4 L1 square and L1 square T1 divided by M1 is equal to 1 upon 4 L2 square T2 divided by M2. Therefore L2 is equal to under root L1 square into T2 divided by M2 into M1 divided by T1. Under is equal to under root 0.6 square into 9 gram divided by 1 gram is equal to 0.6 into 3 is equal to 1.8 meter. The vibrating length of the wire is 1.8 meter. Equation number 5. The equation of simple harmonic progressive wave is y is equal to sin pi by 2 and to bracket 40 under divided by 0.025 minus x divided by 0.25, where all quantities are in SI system. Find the amplitude of the frequency, wavelength and velocity of waves. Solution. For given equation, y is equal to sin under divided pi divided by 2 pi by 2 and to bracket 40 divided by 0.025 minus x divided by 0.25. Y is equal to sin to bracket 2 pi t under root 0.025 minus pi x divided by 0.5. Comparing above equation with y is equal to a sin to bracket omega t minus 2 pi x divided by lambda. Therefore a is equal to 1 meter. Second, omega is equal to 2 pi under root 0.025. Therefore 2 pi n is equal to 2 pi under root 2 pi divided by 0.025. Therefore n is equal to 40 hertz. Third, 2 pi under divided by lambda is equal to pi by 0.5. Therefore lambda is equal to 1 meter. Fourth, v is equal to n lambda is equal to 14 into 1 is equal to 14 meter per second. आन्सर वर्डमध्ये असल्यामुळे या फ्रेम केल्या वर्डमध्ये द ॲम्प्लिट्यूड ऑफ द फ्रिक्वेन्सी वेवलेंथ अँड व्हेलोसिटी ऑफ द वेव्स आर 1 मीटर 40 हर्ट्स 1 मीटर अँड 40 मीटर per second respectively. Question number 6. A stretched sonometer wire is in unison with the turning fork. When the length of the increase by 4%, the number of beats hertz per second is 6. Find the frequency of the fork. Solution. Given L2 is equal to L1 plus 0.04, L1 is equal to 1.04 L1, N1 is minus N2 is equal to 6. To find the initial frequency of tuning fork N1. Cap formula. N1 L1 is equal to N2 L2. Calculation from formula. N1 L2 is equal to N2 into bracket 1.04 L1. N1 is equal to 1.04 N2. Therefore N2 is equal to 1 upon 1.04 N1. But N1 minus N2 is equal to 6. Therefore N1 minus N1 divided by 1.04 is equal to 6. Therefore 0.04 N1 is equal to 6.24. Therefore N1 is equal to 156 hertz. The answer word असल्यामुळे क्वेश्चन वर्डमध्ये असल्यामुळे आन्सर द इनिशियल फ्रिक्वेन्सी ऑफ ट्युनिंग फोर्क इज 156 hertz. येथे आपल्या सर्व शॉर्ट आन्सर सेकंड संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन अपडेट आपल्या चॅनलवर तुम्हाला मिळत राहतील. धन्यवाद.